Hello everyone. So in this video we will see the equivalent resistance problem of infinite ladder. Okay, but before that we need to know some basic concepts. If you already know these concepts, voltage division, current division, then you can skip it. Okay, but let's see. In this question you need to find the value of V naught. So what you can do? There will be some current I. So you can say that the current V equals to I R1 plus R2. So basically your I is equals to V by R1 plus R2. What is your V naught? Let's assume this is ground. So what is your V naught? V naught is I R2, right? This potential. V naught is I R2. So what is the value of I? I is V upon R1 plus R2. So basically your V naught is V upon R1 plus R2. So this is one method of finding V naught. Okay, satisfied with that? Basic network, very basic network, right? Now what I am doing is that, look, this is method 1. Now we will see method 2. R1 and R2 are in series, right? R1 and R2 are in series. If R1 and R2 are in series, that means both have same current, right? Both have same current. Now, by V equals to IR, if current is same, that means V is proportional to R, right? V is proportional to R. If current is same, then your V is proportional to R. That means the voltage across R2 resistor or your V naught, that is equals to R2 upon R2 plus R1 into V. Did you get it? When the current is same, in series the current will be same. So your voltage is directly proportional to the resistance. Higher the resistance, more the voltage. Higher the resistance, more the voltage. That's it. Same goes for inductor, right? Same goes for inductor because resistance and inductors are brothers. Okay. So for inductor, now tell me what will be your V naught voltage? V naught, this is V naught voltage across 1 Henry inductance. So it will be 1 upon 1 plus 2 plus 3 into 6. Basically it will be 1 volt. Did you get it? It will only be 1 volt. Why so? Because of voltage division. Okay, 1 volt by 1 plus 2 plus 3 into 6. So 1 volt. Now tell me about capacitor. Current is same, right? I Q is equals to CV. If I is same, that means Q is same, right? Then what does that mean? V is inversely proportional to 1 by C. Did you get it? So we have to divide it in inverse proportion. So that means this is your V naught actually. This is your V naught. So that means your V naught will be 1 by 2 upon 1 by 2 plus 1 by 3 into 5. It will give you 2 volt. Or what you can do? You have to divide it in inverse proportion. Na? So divide like you have 5 toffees. Okay. You have to divide it in inverse proportion of 3:2. Okay. Inverse proportion of 3:2. That means you have to divide it like this. So you can write it as this as well. 2:3 you need to divide. Means I will give you a simple example. 5 टॉफी आपके पास, ठीक है, 3:2 में बांटना है इनवर्स प्रोपोर्शन में. मतलब राम को आपको 2 देनी है और शाम को आपको 3 टॉफी देनी है. इनवर्स प्रोपोर्शन में बांटना है. इफ यू वांट टू डिवाइड इट इन इनवर्स प्रोपोर्शन, यू कैन गिव इट टू 3 upon 3 plus 2 into 5. This is basic mathematics. I am dividing it in inverse proportion. So while calculating across 2 farad, I will write 3 upon 3 plus 2. Are you getting it? While for 2 components, I can divide it like this. For 3 component, I can't divide it like this. But for 2 component, I can divide it like this. Okay. Now we will see the concept of current division. So in parallel, what is same? In parallel, voltage across resistance is same. VR1 equals to VR2. So by Ohm's law, V equals to IR. That means your I is inversely proportional to resistance, right? So that means the current will be divided into inverse proportion. Current divided into inverse proportion. Into inverse proportion. Okay. More the resistance, lesser the current. What is resistance? Resistance is the resistance. What is the basic definition of resistance? So resistance obstructs the flow of current. It obstructs the flow of current, right? So basically the current is inversely proportional to resistance. More the resistance, lesser the current. Okay. So in this one you need to find the current value. So how will you find it? So I naught will be 1 by 2 upon 1 by 2 plus 1 by 3 plus 1 by 5 into 10. That means your current will come out to be 5 ampere. Okay. If you solve it, it will come out to be 5 ampere. Okay. So if you actually solve it, it comes around 4.8. Okay. Yeah, 4.8. So I just solved it. It's not completely 5 ampere. It's near to 5. It comes around 4.8 ampere. Okay. Now same thing will happen in inductor, right? So your I naught would simply be, you have to divide it in inverse proportion. I can divide it like this: 2 upon 2 plus 3 into 5. That means 2 ampere. So 2 ampere current will go here and 3 ampere current will go here. Lesser the inductance, more the current. Right? 2 ampere will here, 3 ampere will go here. So this is for two component. I can divide it in inverse proportion like this. Okay, 2 and 3. So 2 upon 2 plus 3 into 5, because it will have the lesser current. 3 Henry will have the lesser current because it is bigger. Now talk about this capacitance. Now tell me what will happen. Q equals to CV. I equals to C dVc by dt. V is same. That means I is proportional to capacitance. So in case of capacitance, current is proportional. Okay. So your I naught would be, what will be your I naught? 2C upon 2C plus 2C plus C into 5. Right. So it would be 2 ampere. Right. Very easy concept. Well and good. Current is inversely proportional to inductance and resistance when voltage is same, and voltage is proportional to resistance and inductance when current is same, while current is proportional to capacitance when voltage is same, and voltage is inversely proportional to capacitance when current is same. Okay, very easy steps. You just revise it once again. Okay, very easy. Let's move on to this thing. Just before starting the infinite grid problems, I just want to give you one simple process that I have already told. Like what is the actual meaning of equivalent resistance across two terminals? I told you what is the actual meaning. You apply a voltage and get a current through it. That is the actual meaning. That means you have this circuit and you need to find equivalent resistance across AB. So what you will do? You will apply a voltage source across it. Okay, and get the current out of it, and then your V by I is your R equivalent. Or what you can do, you can apply the current source, any source you can apply, right? Voltage source or current source, and then measure the voltage across this current source. Then your V by I would be your R equivalent. Just notice the sign. The current should get out of positive terminal. The current should get out of positive terminal. From this positive terminal, the current is getting out. If the current is getting into the positive terminal, that means the resistance will be negative. Okay. The current is getting out of the positive terminal, that means the resistance will be positive. Okay. So current has to get out of the positive terminal. Okay. That's it. Very simple concept. So for finding the equivalent resistance, what we can do, we can apply a voltage source and get the current out of it, or we can apply a current source and get a voltage out of it and get the voltage across it. Okay. Now this is the question given and I am asking you what is the equivalent resistance between A and B before starting the problem. Okay, I am just building up the concept. Like when I explain you the infinite grid problem, there will be no confusion. Okay, I am just building up the concept. Okay, so let's just solve this simple question. So this is a network that has a equivalent resistance of R and this is a network that has a equivalent resistance of R. Now you need to find the equivalent resistance between A and B. So what you can do, just replace that network with the equivalent resistance of R. Here we have ground, here you have A, here you have R, this is B, then you have R and then you have ground, right? So between A and B, what you have? Between A and B, there is a resistance R. Between A and from A to ground, there is a resistance R. And then from ground to B, there is a resistance R. Right? Did you get it? Let's assume the ground is some potential C. So here A, B and C. Between A and B, we have R. Ground is some potential C. So from A to C, you have R resistance. And from C to B, from this is also C, right? From C to B, you have R resistance. So this R and R both will come in series. So it will become 2R. Right? So between A and B, you have 1R and 2R. So basically R equivalent between A and B will give you 2R by 3. Well and good. Easy. But now we will solve it with one more method. Okay. Method 2. Solving it using current source. Okay. Now we will solve it using the current source. This is A and B, right? This is ground. This is also ground. I have to find the equivalent. I have to find equivalent across AB, right? So what I will do, I will apply a current source and will measure the voltage across it. Direction should be this. This is R, this is R, and this is R. So my R equivalent would be R equivalent across AB. That would be V by I. Easy. Okay. Well and good. Everything is fine. So my R equivalent will be V by I. So now what I will do? Now what I can do is that if I can calculate the current in this resistance, then the voltage across that resistance will be equals to V only. The voltage across this resistance, the same voltage, let's call it VR. So your VR is equals to V only, na? The voltage across this resistance is equals to V only. And now if I know the current in this resistance, let's assume I know the current in this resistance, that is I dash into R equals to V. Now this I will be function of, this I dash will be function of this I, right? This I dash will be function of this I, and then we will have V. Then we can find V by I from here. So our main target is to find the current in this resistance, right? We want to find the current in this resistance. So for that we will apply superposition theorem. Now what is superposition? Many of you don't know that. Okay. So basically I will just tell you what is superposition. In superposition, if you have two sources, okay, let's assume you have two sources, you can neglect one source, okay, and consider only one source at a time. Neglect one source and consider only one source at a time. Analyze the circuit, get your results. Okay. Then consider the other source at that time. Analyze the circuit, get your results. Then add up those results. You will study it completely in, you will see many examples as well, but in network theorem chapter. That will be the next chapter only. But here I am just telling you, consider only one source and get your results. can consider other source and get your result. We will see it here. So first thing what I will be doing is that this is my circuit. Look, why I am solving this, you will realize it, okay, when we solve the infinite ladder problems. Okay, I am just building up the concept. Like these problems will be there. I am sure you must have seen the solution somewhere, but you wouldn't be having the clarity, like why does it come. So today you will get the clarity. Okay, for sure you will get the clarity. Okay, now what I am doing is that, now tell me, this I current is getting into this terminal A. This I current is getting into this terminal A, right? So I am making it like this, and this I current is getting out of this terminal B. This is something like this, na. You can make it one current source only. The I current is getting into A, then I current is getting out of A, out of B. This is A, this is B. And what I can do is that I can consider a common potential between them, right? I'm not saying it has to be ground, okay? It's not necessary has to be ground. We can consider it to be ground. It can be any potential C as well. It can be any potential. Let's consider it a potential C. Okay, people will get confused between ground. Let's just consider a potential C in between them. Okay, if this is potential C, this will also be a C. I just broke down there. I have just broken down the one current source into two current sources. This current I was getting into the terminal A, and this I current was getting out of the terminal B. So I have broken it down into two current sources. Okay, so what does superposition theorem says? Superposition theorem. Okay, superposition theorem. So I can consider it as two different circuits. I'm just calling it a potential C. This is grounded and this is also grounded. This is R, this is R, this is R. This potential is A, this potential is B. Plus I have to make it minute. This is A, this is B, and there is this current getting out of it, right? And this is not grounded, this is some potential C. Yeah, just assuming some potential C. This is I current is getting in. Now what I will do, I will first analyze this circuit and get the value of AB, or get the current into resistance R in this resistance. Okay, first I will analyze this circuit and get the current in this resistance, then I will analyze this circuit and get the current in this resistance. Now just tell me, if I am assuming this current as IR, now tell me IR1 I am telling. So what is the value of IR1? Tell me. I hope you guys will be able to tell me this, because I have told you the concept of current division. So tell me what will be the value of IR1? IR1 will be 1 by 3I. Did you get it? How did I write it? Here, how much resistance do you see? 2R. And at that side, you see R resistance. Higher the resistance, lesser the current. So inverse proportion. R upon R plus 2R, 3R into I. So I by 3. Got it? Here we have 2R resistance, here we have R. Higher the current, higher the resistance, lesser the current. So inverse proportion, we have to divide it in inverse proportion. So R upon 3R into I, right? So 1 by 3 ampere. Now tell me, again in this resistance, let's call it IR2. What will be the value of IR2? Here higher resistance, here lower resistance. Again it will be 1 by 3 into I. I current is going down. There will be some current coming from here. There will be some current coming from here. Some current will be coming from here. Some current will be coming from here. Right? And in this circuit, some current will be coming here. Some current will be going here. And in this circuit, some current will be coming from here. Some current will be coming from here. But we are considering about this current. Higher the resistance, lesser the current. So here we have 2R resistance. R and R in series. So 2R resistance is there. So lesser current will be there. So 1 upon 3, 1 upon 3 into I. So what is the total current now? What is the total current? So now if I make the circuit again, now I will make, now again I am considering that one source only. I started from here, I broke it down to this, then I went down to this. Now I'm again coming here. This is I, this potential V, this is grounded, this is also grounded, this is point A, this is point B, this is resistance R. Okay. Now what is the total current? Total current is 1 by 3I plus 1 by 3I, 2 by 3I. So the total current here is 2 by 3I, right? 1 by 3I, 1 by 3I was in this direction, 1 by 3I was in this direction. So total current is 2 by 3I. So basically your V is equals to 2 by 3I into R. So your V by I is equals to 2 by 3 into R. This is what this was the answer only we got now. Previously, this was the answer only we got. Look, why I am trying to solve it with this complex method, you will realize it in the next slide only. But just see this. What did I do? I broke down the current source into two, because I current is going out of here, I current is going into the terminal A, and I current is getting out of terminal B. So I broke it down like this. Then I applied superposition theorem. I will consider only one source at a time. I consider this source at the time and calculate the value of IR1. I got 1 by 3I. Then I consider this source at that time and calculate the value of IR2. I got 1 by 3I. So then adding both of the current, my total current in this resistance is 2 by 3I. Right? My total current is 2 by 3I. So basically V equals to 2 by 3I into R. So my V by I is 2 by 3R. So this is my final answer. Did you get it? Say yes. You must have got it. Now solve this problem. This is an infinite ladder. Okay. And each branch represents a resistance R. So this is a resistance R, this is a resistance R, everything a resistance R. Okay. So each branch represents a resistance R. Now you have to find the equivalent resistance between A and B. What you will do? You will apply a current source like this. Then what you will do? You will consider this current source as two sources. Now someone will say, like, infinite ladder is there, right? Now you will say that where is the ground? So infinite is ground only. If they are saying that infinite ladder is there, that means at infinite there is ground. All of these are grounded. Okay, all of these are grounded. Okay, so like, who thinks more, he can think that, oh, there is no ground, so there should be no current. There would be current. Okay, if it is till infinite, that means there is ground. Infinite is ground only. Okay, so what we will do, we will consider two sources, one current source I, one is going in. Now I is going in, so tell me what will happen. Here we will have I by 4, right? This I has 4 branches, this branch, this branch, and this branch, and this branch, and at all 4 branches. From here if you stand, you will see there is infinite ladder. From here you will see there is infinite ladder. From here you will see there is infinite ladder. From here you will see there is infinite ladder. So across all it sees equivalent resistance. So it will be divided into 4 equal parts, I by 4, I by 4, I by 4, and I by 4. Now what we will do, we will consider a current source at B as well, that is getting out, right? This current I is getting out. Now this current I is getting out, that means some I by 4 current would be coming from here, some I by 4 current would be coming from here, some I by 4 current would be coming from here, and some I by 4 current would be coming from here. So between A and B, basically we have a resistance. Between A and B we have a resistance where I by 4 plus I by 4, I by 2 current is there, right? And we have a current source across it of I with voltage of V. We have a current source of I with voltage of V. So basically V is equals to I by 2R. So V by I is equals to R by 2. So our R equivalent is R by 2. Did you get this or not? I hope you have understood this. I spent a lot of time here. Just because you will understand it very clearly. Between A and B, there is one current source. We consider it as a two current source. We consider only one at a time. So we forgot about B. We only consider A. Because of that, I by 4 current. Now considering about B. So because of B, there is I by 4 current. So total I by 2 current. So I by 2 into R. So V by I is R by 2. That's it. Well and good. Now I hope you are able to understand this concept very clearly. Okay. So I hope this everything was used now. Okay. This voltage division or current division was used here actually. Like current division was used here. So that's why here we use current division. That's why I taught those concepts. So I hope now you can relate everything, right? Try finding the equivalent resistance of this on your own. Okay, on your own. What you will do? You will connect a current source between these two terminals, and you will need a voltage across them. Okay, so do it. What you will do? I current is getting into it. So here I by 4, and here also I by 4, I by 4, and I by 4. Okay, now think about this. Now this I by 4 current is going here. So it has 3 different paths, right? For this I by 4 current, it has 3 different paths. So I by 12 will go here, I by 12 will go here, I by 12 will go here, right? I by 4 has 3 different paths. I by 4 by 3 into 1 by 3, and I by 4 into 1 by 3, I by 4 into 1 by 3. So 3 different paths it has. So I by 12, I by 12, and I by 12. So because of A, this is happening. Now because of V, what will happen? Let's use some different color. Can we use green? Can we use this color? Yeah, it will be seen. Okay. So from here, the I current is getting out. So what will happen? From here, I by 4 we will have, it's not visible. I guess I will have to use green only. Not green, this yellow. So I by 4, I by 4, I by 4, and I by 4 here as well. Okay. Now I think I can write it down like this, I by 4. Now if I by 4 is coming, that means it would have been coming from 3 different paths like this, right? So I by 12 would be coming here, and I by 12, and this would also be I by 12. So basically this is point A, then you have a resistance, then you have this point, and this is B, right? In this resistance you have I by 4 plus I by 12 current. Look, I by 4 here, if you are confused about this, I by 4 current was going that side. That means I by 12 from here, I by 12 from here, I by 12 from here, right? I current was getting out, then I by 4, I by 4, I by 4, I by 4. If I by 4 here, then I by 12, I by 12, and I by 12. Got it? So here we have I by 4 plus I by 12. That means we have 4 I by 12. That means we have 4 I by 12 means I by 3. And here also we have I by 3. Right? Did I do it right? I 1 by 12 plus 1 by 4. 3, 12, 4 by 12, 1 by 3, right? So I by 3 current that side, I by 3 current that side. So let's assume it has a potential of VA, it has a potential of VB. So VA minus I by 3R minus I by 3R equals to VB. So your VA minus VB, that would be equals to V only, right? Because we applied a current source like this. We applied a current source like this, and this was our potential. This was our potential, right? So higher potential at A, right? Higher potential at A. So VA minus VB would be equals to over V only. That would be equals to 2I by 3 R. That means your R equivalent will be 2R by 3. Very interesting problems, and till now it hasn't been asked in gate. It is asked in JEE many times, but not in gate till now. So I can expect infinite ladder question in gate. Okay, anytime I can expect questions, and many students don't put so much notice there. Okay, because they think equivalent resistance, oh, that is easy, but this is the actual concept. I hope you are getting the concept now. Okay, so just we needed to calculate the current between these two, or you can calculate the current between these two as well. Like here as well, you could have calculated the complete current, right? Like this I by 4 current would be getting into two parts, like I by 12, three parts actually, I by 12 and I by 12. Okay, then also this I by 4 would have been getting into three parts, I by 12, I by 12, I by 12. I won't make the complete circuit, it will make it look more complex. So now I think you can visualize it, right? I current is getting into it, I by 4, I by 4, I by 4, I by 4. Then I by 4 is getting divided into three parts, I by 12, I by 12, I by 12, right? And then this I current was going out, that means I by 4, I by 4, I by 4 and I by 4, and this I by 4 would be coming from I by 12, I by 12 and I by 12. So basically here we have I by 3 current and here we have I by 3 current. So your VA minus VB is basically equals to 2I by 3 into R. So your R equivalent is 2R by 3. So now the equivalent resistance problem is solved, right? So these were two complex problems that many of the students aren't able to get it. Like every teacher will teach you the I current will go out, I current will get out, and then you need to analyze it. But this is the actual concept. From this problem we learned this concept, right? We studied this concept from here. From here we understood this concept that one current goes in, then we are applying the superposition, then other current goes out, then we are applying the superposition. I hope you have understood the complete concept now. Okay. Now see these problems that we have solved in secondary classes, higher secondary classes as well. But let's just see. Now you have to find the equivalent resistance across A and B. Okay. Now if I forget about this, this is also infinite ladder. Okay. Now let's just forget about it and come here. If I come here and see from here, I was looking from this side, I was looking from here, I could see 1 by 1 2 1 2 1 2 1 2, right? Okay, yeah. And if I come at this side now, what I will see? 1 2 1 2 1 2 1 2. This is the same only, right? I can see the same things, na? If I am saying from here and if I am saying from here, I can see the same thing. So if from here it is R equivalent, so from here what it will be? It will also be R equivalent only. If seeing from here I am saying it is R equivalent, then seeing from here I will also say it is R equivalent only, right? So this is 1 ohm, this is 2 ohm, this will be replaced with R equivalent. This is 1 ohm, this is 2 ohm. So basically this will be your R equivalent. So what will be your R equivalent? R equivalent will be 1 plus 2R equivalent upon 2 plus R equivalent. Okay, it will give rise to a exponent. It will give rise to a equation that you need to solve. Equation of power 2. Quadratic equation it will make. Okay, so R equivalent square plus 2R equivalent. Okay, I will just solve it and write down the final answer. Okay, so basically after solving it we get R equivalent equals to 2 ohm. Okay, here you can clearly see if I put R equivalent equals to 2, 2 and 2 will become 1 and 1 and 1 will give you 2. So R equivalent is basically 2 only, right? So R equivalent you are getting as 2. Okay, now you can't really see the complete problem, so I will have to shift it, I guess. Wait. Okay, so this is the problem. Okay, so what is that problem? Let me explain you. From point A, 1 R and 1 R is getting divided, then 1 more R, then this R is also getting divided, this R, and it goes on. Every R is getting divided into two parts, R, then RR, like this. Now I will do one thing. If I come here, what do you think? What will be this node? isn't it same as A? Forget about it. I'm saying I am calculating R equivalent from here. R equivalent from this side. I think I should change the color of the pen. If this is R equivalent, for me, this is R equivalent. So now tell me what will be this? Isn't it the R equivalent only? Because from one point, two resistance, then two resistance, two resistance, two resistance, two resistance, two resistance. This is R equivalent only. And isn't it the R equivalent only part? Because from one point, two resistance, then two. This is what is happening here. One point, two resistance, two resistance, two resistance, two resistance. From here as well, one point, two resistance, two resistance, two resistance. Right? So between A and B, what I can do now is that this is my A. A has R and then R equivalent. Then directly we have B. Again we have R and R equivalent. This is R equivalent, this is R equivalent, and this is our R equivalent we are calculating. So our R equivalent will be equals to R plus R equivalent by 2. So your R equivalent is coming out to equals to R only. Did you get it? वीडियो चल रहा है, मैंने बोला वीडियो स्टॉप हो गया. हाँ, तो R now this I replaced with R equivalent, and this also I replaced with R equivalent. Then directly I had B, so, and here I here I had R equivalent. So R plus R equivalent by 2. This will give me R plus R equivalent by 2. So R equivalent is equals to R plus R equivalent. So R equivalent is equals to R. This is my final answer. Okay, so let's move on to the next problem. Now this problem. Now try solving it on your own first. Let's just see one concept. Tell me what is the equivalent resistance here? What is the equivalent resistance? R. Now if I multiply this ladder with 2, I am multiplying it with the factor of 2. Now what is the equivalent resistance? 2 R equivalent. Means that now what is the equivalent resistance? If this was R equivalent, I will call it R equivalent dash. That means your equivalent resistance is doubled, right? Okay. Now use this concept and solve this problem. Like if I multiply a ladder with some factor, your equivalent resistance will increase by that factor, right? So now what I do, multiplying this ladder with 2, multiplying this ladder with 2. So I will again make it. So if I multiply it with 2, so what will this become? It will become 2R equivalent. This will become 2R, 2R, 2 square R, 2 square R, 2 cube R, 2 cube R. Every factor is multiplied by 2. So 2 4R and 2 4R, and it goes on till infinity. So now if this is R equivalent, what do you think what this is? This is 2R equivalent, because this letter shows 2R equivalent. So basically your finally between A and B, what you can do? This is R, this is R. You are calculating your R equivalent here, and from here what do you see? 2R equivalent, right? From here you are seeing 2R equivalent. This was R, this was R and R, this was R and R, and after that this is 2R equivalent only, because if we multiply it with the factor of 2, it will become like this. And if it is becoming like this, that means from here we can see 2R equivalent. From here we can see 2R equivalent. So basically your R equivalent will be equals to R plus 2R equivalent into R upon 2R equivalent plus R. So from here you can calculate the value of R equivalent. Okay, let me solve it and write it. So the final answer we get is 1 plus root 5 by 4 into R. Okay, 1 plus root 5 by 4 into R. Okay, well and good. Let's move on to the next problem. A similar kind of problem we have solved. Now this is not for infinite ladder. This is simple equipotential or symmetry problem. So shall I leave it on you? Will you do it on your own? Okay, I will solve it, but you should do it on your own. Okay, so tell me what will be the axis of symmetry in this question. What will be your axis of symmetry? This will be your axis of symmetry, right? You will make this R as 2R and 2R, right? This will be 2R and this will be 2R. This will be 2R, this will be 2R, and this will be 2R, and this will be 2R. Now this 2R, and if this is the axis of symmetry, that means it will be a line, straight line, right? It will be a line, it will be a straight line. That means it is a straight wire with no resistance. So this effect of 2R will be gone, right? Are you able to understand? If you make a symmetry here, then the effect of that 2R will be gone, right? I told you about this concept. When we have a resistance R, any resistance R dash, let's call it, and then it is connected to a simple wire with no resistance. That means its final resistance will be 0. It will be a simple wire only, right? So now what will happen? Now this R, this R, this R, this R, this R, and this R, all R will come in parallel. So from A we have, here we have R by 6, because R and R, all R will come in parallel. So this will be R by 6, and at B here we will also have R by 6. So between A and B, R equivalent between A and B, we will have R by 3. So R value is 300. So our answer will be 100 ohm. Got it? We applied the concept of symmetry from here. So this R and everything, it goes to 0. Everything goes to 0. That means R by 6 and R by 6. So it is R by 3. So your R equivalent is 100. Okay. You can solve it with the concept of equipotential as well, but it will take time. But you should solve it. For your practice, you should solve it with the concept of equipotential. Concept of symmetry, we have solved it. Okay. You should solve it with the concept of equipotential as well. Now this one, how will you solve? The concept of symmetry or concept of equipotential? Basically, in this question, what you need to do, you need to find the equivalent resistance between these 2 points, right? Between A and between B. You need to find the equivalent resistance between these 2 points. That's the only thing you need to do here. So that's how you will bisect it. But I guess it will be a bit tough. You should solve it on your own for concept of symmetry. I will solve it with the concept of equipotential. So let's just call these 2 points as AB, these 2 points as C, D, and E, F. You need to find the equivalent resistance between A and B, so that you can replace this complete circuit with a single resistance. Then there will be 11-volt battery. Then you can find the current, right? So we are replacing this A and B, between A and B, we are replacing it with the one simple resistance. So what we will do? So now tell me if this C and D are equipotential or not. From C to A, you will go. From C to A, you will go. We are commenting about C and D. From C to A, you will go. You will find R resistance. From D to A, you will go. From D to A, you will go. You will find R1. R1, you will find R1. Well and good. Matched. Okay. From C to B, you will go. You will find R1 plus R1. And D to B, you will go. You will find R1 plus R1. Matched. Well and good. C and D are equipotential. Similarly what? E and F are equipotential. Okay. So this R2 resistance will have no use. So basically R1, R3 and R1 all will come in parallel, and this R1 and R1 will come in parallel. So basically between A and B, what we will have? R1 by 2. This is A. Then we have R1 by 2. Then this resistance will be R1 parallel with R1 parallel. This R1 and R1 came in parallel. This R3 and R3 came in parallel. This R2 is gone. This R2 is gone because both of them are same points now. Both of them are same nodes now. So only this R1, R1, R3, R3 are left, right? So R1 parallel R1 parallel R3 parallel R3, and these points are R1 by 2, and this is point B. So R1 by 2 plus R1 by 2, this will become 1, and R1 values are given there, right? R1 value is 1, 1 by 2, 1 by 2. So basically by putting the value, if you solve it, it will become 11 by 8 ohm. Okay, 11 by 8 ohm. Between A and B we will have 11 by 8 ohm. So what will be the current? 11 by 8 ohm, we have a battery of 11 volt. 11 volt current. What will be the current? V by R, that means 8 ampere. This is your answer, 8 ampere. Got it? Your current is 8 ampere. Concept of equipotential, R1 by 2, R1 by 2. This you should be able to solve. This is a gate question only. If you have solved it by your own, then it is very good. Like these problems you should be able to solve on your own. Okay. So now I think this is the last problem on equivalent resistance. In assignment we may have some problem on equivalent resistance, but I guess you are completely comfortable. Now there is not a single type of problem that I have left. There are types of problem, like there can be infinite problems, but all the types have been covered. And I will go like this in all the subjects that I teach. I will cover every type of problem. Okay. Now the rest thing is your practice. You need to practice on your own. Okay. So these kind of problems you should be able to solve. CD equipotential, EF equipotential, R1 by 2, R1 by 2 here, then all these come in parallel, then equivalent resistance and simply the current. That's it. Okay. Now we will see the method of analysis from where most of the questions are asked, like mesh analysis, nodal analysis, super node, super mesh, or any kind of circuits. Okay. So we will just see it in next video. So we will solve many questions there, and it will be all easy for you then. Okay. So if you are liking the content, please do share it with your friends. Okay. Thank you.